Sound check, sound check. Chemistry, this is the answers video for the first lesson, Unit 1, Lesson 1 Math for Chemistry. So I'm going to give answers to selected problems here, and you do the ones, you do all of them, okay? So I'm really going to be looking at the ones that I didn't do on this video. Okay, we did a number of these in class. Let's get started. So adding and subtracting fractions, you can use the crossing arrows method. Take that denominator. The top of a fraction is called the numerator, the bottom is called the denominator, and you move it over here and you multiply the top and the bottom by that. Then you take this one and bring it over here, top and bottom. So now you have 4 multiplications. 2 times 2 is 4, 2 times 3 is 6, plus 1 times 3 is 3, and 2 times 3 is 6. So the whole object is to get a common denominator, the same number on the bottom. You must do that in order to add or subtract a fraction. So now it's simply 4 plus 3 equals 7, and the 6, the denominator, does not change. You only add the numerator part of it, and there it is. Okay? All right. By the way, this is called an improper fraction. The top is bigger than the bottom. In this class, you're welcome to leave a fraction as an improper fraction, but we'll talk about converting to a mixed fraction in just a moment. Okay, same thing here. 5 3 times 3, 3 times 5, 1 times 5, 3 times 5, 9 minus 5 is 4, and again, you don't change the denominator, it stays as 15, so 4/15, okay? Do one more. You do not have to draw the arrows if you feel like you get the concept. 4 times 2. Okay, there's the answer. You do this one. Okay, we'll keep going. Okay, I'll just do a couple of these. You multiply across, straight across top, straight across bottom. You do multiply the denominator as well as the numerator. So 2 times 4 is 8, 3 times 5 is 15, and that would be your answer. Okay, now if you can, you want to cancel before multiplying. So you can cancel across a multiplication sign, a time sign. You cannot cancel across an addition, subtraction, or division sign. But if it's a time sign, you can cancel across it, just like if it were right over the number. So 4 goes into 4 one time, 4 goes into 8 2 times, 3 goes into 3 one time, and 3 goes into 9 3 times. You've reduced it as far as you can, so now again you multiply straight across. 1 times 1 is 1, 2 times 3 is 6. Okay, and that's how you do multiplications. You do these two down here. Okay, division. So I'll do the first two. So the rule for division is flip the bottom and multiply. So I'm going to come over here and write 2 over 7 times, and the bottom you can flip it, 5 over 4. Instead of 4 over 5, it's 5 over 4 right there, okay? Now, if you can cancel, go ahead and do that. 2 goes into 2 one time, and 2 goes into 4 2 times. Okay, you can't cancel the 5 and the 7. So 1 times 5 is 5. 7 times 2 is 14. So there is your answer. Okay, when it's a whole number or an integer, whatever you want to call it, pretty much the same thing, not exactly. You put in 1 underneath any whole number or integer to make it a fraction. So this is going to become 6 over 1, this right here, and then the bottom is already a fraction, 3 over 4. Now you can just do what you did on the previous problem. Keep the top the same, the numerator stays the same, you flip the bottom. Okay, 3 goes into 3 once, 3 goes into 6 2 times. 2 times 4 is 8. 1 times 1 is 1. You don't have to write the 1 on the bottom, so the answer is simply 8. Okay, so you're going to go ahead and do this one. Okay, converting from improper fraction, which is where the number in the numerator is bigger than the number in the denominator, to a mixed fraction. The advantage of an improper fraction is if you need to do further math on this fraction, you can do it in this format, in a mixed fraction form. You can't work mathematically, with an improper fraction. With a mixed fraction, you can't work with it mathematically. You would only switch an answer to a mixed fraction if it's your final answer and you're totally done with the problem. Okay, but that's why I'm okay with you leaving it like this, because oftentimes when you come up with a fraction, you're going to need to do further math on it, in which case you're going to have it in this form. Okay. All right, so what you do is you simply do a little division problem. So what a fraction really means is 2 divided into 7. So we're going to write it like that. So 2 goes into 7 3 times. 3 times 2 is 6. You subtract that. 7 minus 6 is 1. And you're done. You're not going to do any decimal here. So you have a remainder. This number outside the bracket is called the divisor. This number inside is called the dividend. You don't really need to know that, except it helps us to communicate. So what you do is you take your answer on the top, 3, and then you make a fraction out of the remainder and the divisor. So it's 1 over 2. It's the remainder over the divisor, and that's how you would do that. Okay? All right, you can do this one. Let's go ahead and do this one now. This is going in the other direction. It's going from a mixed fraction to an improper fraction. So you use the round the world method. You multiply this number, this denominator, and this number out here, multiply them. And then you take that and you add it to that number. And then whatever you get from all that, you put it over this number. Okay, so you kind of go around the world like that. Okay, so let's do that. 5 times 2 plus 4. And then you put all of that over 5. Okay, and PEMDAS tells you that you should do the multiplication first. So 5 times 2 is 10, plus 4 is 14 over 5. So the answer is 14 over 5. If you want to prove that that's correct, just do what we did up here. 5 divided into 14. 5 goes into 14 2 times. 2 times 5 is 10. Subtract, you get 4. So you get 2 and 4 over 5. 2 and 4/5. You don't have to do what I just did. I'm just showing you that, yeah, you end up back where you started there, okay? So you do these two. Okay, dimensional analysis is really important in chemistry. We did A and C in class. We're going to actually do more of them in class. So here's how you approach this. It's asking how many inches in 5.2 feet. And it's giving you a relationship between inches and feet. You have to have that, otherwise you can't do the problem. And most of you, I think, know that there's 12 inches in 1 foot. So the way you set these problems up, you're writing a math equation. Over on the right side, you ask yourself, first of all, what is the question trying to find in the end? What unit of measure? And the answer is it's trying to find inches. So I'm going to come over here, I'm going to write inches. That's the abbreviation. And I'm going to draw a little underline, put an equal sign. So in other words, my final answer is going to go right there. I'm setting up a math equation. Now what we're starting with, the thing we know that we're starting with is 5.2 feet. So I'm going to come way over here, leave a lot of space in between, because sometimes you don't know how many conversions you're going to need here. So 5.2 feet, okay? And we're going to need to multiply it by what's called a conversion factor, okay? So that feet disappears and inches appears in our final answer. So you can make 2 conversion factors out of any equivalency. It's real simple. You just take this one of them, and put it over the other, and then you flip it. So the 2 conversion factors would be there's 12 inches for every 1 foot, or there's 1 foot for every 12 inches. Those are both true statements. Think about it. You could say that sentence in either order. There's 12 inches for every 1 foot, or there's 1 foot for every 12 inches. So those are both true statements, all right? So these are both true, but only one of them is going to help us, is going to go in there to solve the problem. So which one is it going to be? Well, we need feet to cancel out because it doesn't appear in our final answer. And we need inches to appear on the top because it does appear in our final answer. So the one we're going to pick of these two is this one. That puts inches on the top and it puts feet on the bottom. So 12 inches. 1 foot. So feet on the top. Remember, if the number's only on one level, it's on the top. It's in the numerator. So feet cancels on top. Remember, you can cancel across a time sign. So you can cancel units of measurement just like you can cancel numbers or variables. Now, if you don't know what a unit of measurement is, that's why you watch the video. The lecture video explained that to you, what a unit of measurement is, okay? So now we've canceled feet. The only thing we have left is inches, and that's what we want in our final answer. That's the way these problems have to work out. Whatever the unit is that you didn't cancel has to be the same as the one in your final answer, or you did something wrong. Now that you have it set up correctly, though, you multiply everything on the top and divide by everything on the bottom. So 5.2 times 12 divided by 1 is 62.4, okay, is what we came up with. So that's your final answer. This times this divided by this. Okay. How many inches in 1 mile? Again, it's asking us for inches, so I'm going to come way over here. Inches. That's where my answer is going to go. 1 mile. So I'm going to start way over here with 1 mile. Now, we have two equivalencies, and neither one of them relates miles to inches. You don't see one. This one's inches to feet, and this one's feet to miles. So we're going to need both of those to get to our final answer. So we're going to need two conversions. So I'm going to draw two boxes. One of the conversion factors is going to go there. One of the conversion factors is going to go there. Okay, now you need to make your conversion factors out of these two equivalencies. There's going to be 4 of them. There's 12 inches for every 1 foot, or you could put an equal sign there, but I put an or to emphasize you're only going to choose one of them. There's 1 foot for every 12 inches. So those are 2 of your conversion factors. Now for this one, you can also make 2. There's 5,280 feet for every 1 mile. That's a true statement. 1 mile, just leave this MI. Or there's 1 mile for every 5,280 feet. So you have 1, 2, 3, 4 conversion factors. Which one goes in the first box? Well, we're starting off with the unit of miles, and that doesn't end up in our final answer, so we need to get rid of it. So it needs to cancel out. So which one of these 4 would you pick? You need one with miles on the bottom, and there's only one of them that has miles on the bottom, and that's this one right here. So that's going to be our first conversion factor. And we can go ahead and cancel miles and miles. We're not canceling numbers. We're not doing anything with numbers. We're canceling units of measure. Okay, so that means we've used this one. We're done with it. We're also done with its cousin, the other one that relates those two. We're done with that one. We're not going to use that one either. So now we have these 2 left. Which one goes here? Well, we have feet on top, so we're going to need feet on bottom. And we have inches in our final answer, and we need inches on top. So it's going to be this one. So feet on top cancels with feet on bottom, and inches here is the last man standing. Right there. So now what you do, you know you have the problem set up correctly. Now you're ready to deal with the numbers, to do the number crunching. So it's everything on top you multiply. 1 times 5,280 times 12, and then you divide by everything on the bottom. Divided by 1, divided by 1. So I'll go ahead and get a calculator here and do that. Okay, and it might be a little bit of glare here, but it's 1 times, and I think you know you don't really have to multiply by the 1, right? But go ahead just to make it thorough. 5,280 times 12 divided by 1 divided by 1, and you get 63,360. Let me just write it down here. And you got to always write the units of measure too, inches. So that's your final answer, okay? Okay, so I've gone ahead and given you the answers for 4B and 4D. You go ahead and work them. You got to show your work on these, and these are the ones I'm going to check, the ones that I didn't do for you here. And you got to show your work the way we did in these problems here, okay? Don't just write down an answer. You've already got the answer. Let's do E together. Okay, so it's dealing with how many micrometers, okay? That's 1/1,000,000th of a meter. All right, so there's 1,000,000 micrometers in 1 meter. All right, are in 2.2 meters. So it's asking you for a final answer in micrometers. That's the Greek letter mu, mu. And that's what we want to get to. And we're going to start off with 2.2 meters way over here. And there's only one conversion factor equivalency, so you're only going to need one conversion here to get from meters to micrometers. Okay, so you can make two conversion factors. There's 1 meter for every 1,000,000. For every 1,000,000, there you go, 1,000,000 micrometers. Or there's 1,000,000 micrometers for every 1 meter. So what do you need to cancel out here, and what do you need to appear on the top? You need meters to cancel out, so that has to be on the bottom right here. That's this one. So we're going to write that over here. Micrometers over 1 meter. Meters cancels out, and micrometers. Okay, and so you have the last man standing is what you need in your final answer. So 2.2 times 1,000,000 divided by 1, I'll write it down here. It's 2,200,000 micrometers. Okay. All right, we're going to move on. And I'll leave F for you to do. I'll give you an answer for it. How many grams in 785 milligrams? A milligram is 1/1000th of a gram. So the answer you're going to come up with is 0.785 grams in 785 milligrams. Okay, so you do that one, but show the works. Okay. All right, scientific notation. So the way you do scientific notation is you convert from a decimal number. A decimal just means a regular number. Put the decimal point where it should be. You don't see one here, but it's implied right there at the end. So you need to create a number between 1 and 9.9999999. In other words, not 10, but all the way up to 10. So where would you place that decimal to do that? You'd place it right between the 2 and the 3. 2.34 would be a number between between 1 and 9.99. So I'm going to count how many places. 1, 2, 3, 4. You had to move it 4 places. So what you write is the coefficient. Again, I'm assuming that you watched the video, so you kind of know, what we're doing here. Okay, if you didn't watch the lecture video, then I'm kind of going past you a little bit. So it's 2.34. You don't need to include the zeros, times 10, and you move the 4 places, so it's times 10 to the 4, but is it positive or negative? So just ask yourself, is this number that we started with bigger than 1 or smaller than 1? Not negative, but smaller than 1. Well, clearly 23,400 is bigger than 1, so it's a positive 4. So it's 2.34 times 10 to the 4th. Okay? How about this one? Okay, move it to create a number between 1 and 9.999, so that's going to be 3.2. So you move it 1, 2, 3, 4, and you get 3.2 times 10, and you moved it 4 places. But now you ask, is that number bigger than 1 or smaller than 1? And that's clearly a number smaller than 1, so it's going to be a negative 4. It doesn't make it a negative number. It makes it a positive number between 0 and 1. In other words, a decimal number. Okay? I'll do one. Let's do one more here. So this one, you have to move over 2 places. So it's 2.05 times 10. And you moved it 2 places. And you started off with a number that's less than 1. 0.0205 is less than 1, so it's going to be negative 2. Okay? I'll leave you with this one to do. Okay? Question is, do you have to put all 5 of those digits in your scientific notation? Answer, yes. You can lop off zeros like we did over here, but you can't lop off any other digits, all right? Okay, now let's go in the other direction. 4.2 times 10 to the 3rd. Okay, so what you do is you take the coefficient, that's this number here, you write it out, and then you move the decimal this many places. The only thing you have to decide is it to the left or to the right. Well, 10 to the third is 1,000, so this is definitely a number bigger than 1. So you're going to move it to the right. Your common sense would tell you got to move it this way to get a number bigger than 1,000. And those empty spaces you fill with zeros. So your final answer is 4,200. Okay, don't leave it like that. Okay, rewrite the number. Okay, let's do this one. Go ahead and do this one. So you go ahead and write the coefficient 0.0244. And now you're going to move it 6 places. The question is to the left or the right. Well, this is clearly, -6 is clearly a very small number, much less than 1. So you're going to move it to the left. Okay, so we're going to go 1, 2, 3, 4, 5, 6. So again, that's how many spaces, how many loops you make. 1, 2, 3, 4, 5, 6. And that means we're going to put zeros in all of these places here. Okay, you already had a 0 there, a leading 0, that's fine. So we're going to write it, always put a leading 0 point, and then you got 1, 2, 3, 4, 5, 6. And then you got another 0 there, 7. 1, 2, 3, 4, 5, 6, 7, and the 2, 4, 4. Okay, that's how you do these. All right, let's do one more, just in case this is still a little vague. So 9.82. This means it can be a number less than 1, so you're going to want to move the decimal to the right 3 places. To the left, excuse me, say that again. Move it to the left 3 places. 1, 2, 3, it goes right there. 2 empty spaces right there, put zeros in. So your leading 0 always goes in front of the decimal. That's not one of these 2, it's one out here. And it's 0.0982, okay? And that's the answer for that, okay? You do this one by yourself. Okay. Now we're going to multiply scientific notation numbers. The rule is you multiply the coefficients and you add the exponents. So adding a negative number would be subtracting, okay? So 5.2 times 2.8 equals 14.56 times 10, and 5 plus -3, or 5 minus 3 is 2, 10 to the 2. Now you have to adjust the decimal. This has to be a number between 1 and 9.999. So what I'm going to do is move this decimal over to there and make this 1.456. Now it is a number between 1 and 9.999. But you just can't move that decimal without changing something else. You don't want to change the value of the number. So I'm going to make it times 10 to the third. And the reasoning is this. You made this number smaller by 1 position. You moved the decimal 1 over. So to compensate for that, you have to make this number bigger by 1 position. So go from 2 to 3. When you go from 14.56 to 1.456, you've divided by 10. This divided by 10 gives you this. When you increase an exponent of a 10 by one number, you've increased by 10 times. So divide by 10 times is offset by multiplying by 10 times. Again, just focus on the idea that if you make this number smaller, you have to, if you make this number smaller, you have to make the exponent bigger. If you make the coefficient bigger, you had to make the exponent smaller. Okay? Let's do a couple more of these. All right. So this one is 0.2 times 6.1. That's going to give you 1.22. So that's already a number between 1 and 9.99, so you're not going to need to adjust the decimal. Times 10, -9 plus 3 is going to equal -6. Be sure you don't mess up your negatives and adding and subtracting negative numbers. Be careful on that, okay? So -9 plus 3 gets you, it goes in the positive direction, so it gets you to -6. Okay, let's do one more here. 2 times 9 times 2.9 times 9.1 equals 26.39 times 10. -2 plus -5 is the same as -2 minus 5 is -7. Okay, now we're going to make this number smaller to get it to be a number between 1 and 9.99. So that means we have to make this number bigger. When you make a negative number bigger, which way do you go? you go in the positive direction. So it goes from -7 to -6. So this number became smaller by 1. This number became bigger by 1. Right, you do the last one on your own. Okay. In the interest of time, I'm just going to do one of these. Okay, I'll do this one. So now division, you divide the coefficients and you subtract the exponent. And be careful, subtracting negative numbers. Students make mistakes on that all the time. So I'm going to do 3.2 divided by 6.4, and that gives us exactly 0.5. Now be careful, -2 minus -7. I would write that one out. -2 minus -7. A negative becomes a positive. So it becomes -2 plus 7. And some students like to switch it around and put the positive number in front. That would be 7 minus 2. That equals 5. Okay? So that's going to be your exponent. 10 to the 5. Now, this is not a number between 1 and 9.999, so we need to move it. Where to? Well, you need to move it to this side of the 5. You need to actually make this number bigger. So from 0.5, it becomes 5. Since we made this number bigger, we have to make this one smaller by 1. So it's times 10 to the 4th power. Okay, and that's the answer for this one. All right. Okay, now we're going to just practice putting these symbols into actual scientific notation numbers. Okay, so 320 milligrams, there's milligram right there. It's 10 to the minus 3. So what you would write is 320, that's not as hard as it looks, times 10 to the minus 3. So this 10 to the minus 3 took the place of this m. But you still have to write the G for grams, what the unit of measure is. So it's that many grams, okay? 52 centimeters is 52 times 10 to the what? Come up here, small c is 10 to the minus 2. So this takes the place of the c, and then you still have to put the meters over here. Okay? So we did all of these in class at one point. So 101.5 megahertz, 101.5 times 10 to the 6, 10 to the 6, that's a million. And that takes the place of the m, but you still have to put the HC. Now you may say, shouldn't you convert this to a number between 1 and 9.999? The answer is no, because usually megahertz is expressed in 90s, hundreds, somewhere, what radio station, it's a radio station call number, right? So 101.5. So in this case, you can make an exception to that, all right? Let's do one more, 6.3 nanometers. So 6.3 times 10, small n is nano right there. Okay, it's 10 to the minus 9, and it's meters. Okay, and that's that. Okay, so I'm going to wrap that. I think that's it. Yeah, that's it. So if you have questions on any of the others, I've got lots of time for tutoring. Come in, or you'll get these done in class.